Hello, you're watching Unit 7, Lesson 2 on multiplying polynomials for Mr. Dougherty's Algebra 1 class. This should be a review, but it's our introduction to flipped classroom. What I'm going to try to do here is come up with a way for you to watch the lesson at home, do a little bit of practice, and that way we can do practice together in class. It might be very effective and efficient, specifically for this unit because it's mostly procedures. It's not a lot of application. And this is a good review lesson to start with. I'll try to keep this under 10 minutes. First, we're going to use the distributive property, and we're going to multiply 2x times 3x minus 1. This should be a very simple review. I take the 2x and I multiply it by both terms, 3x minus 1. That's a binomial, as we know from yesterday's lesson. 2x times 3x gives us 6x squared because we add the exponents when we multiply terms with like variables. Then 2x minus 1 is minus 2x. This binomial is already in standard form, so we really don't have to do much to it. It has a degree of 2 because the highest exponent is 2. The next example is a little more difficult. You should pause this and see if you need to. You can check your answer when you're done. My suggestion will be to watch the signs. Okay, there's the answer. Negative 4x cubed, y to the fourth, plus 10x cubed, y cubed. Now I paused the video. This is my second attempt because I noticed while I was talking, it's possible I could make a mistake. So I want you to be careful when you do this as well. Don't be multitasking. Focus on the one thing at a time, and we'll get the answers all right if we're careful. The next example I have is of the double distributive property, also known as FOIL. Your parents and I all learned it that way as FOIL. And what we'll do is we'll multiply x plus 2 times x minus 6. Now the reason we call it FOIL is because when we distribute the first term in the first binomial that to the first term in the second binomial, that would be the f. Then we multiply the x times the negative 6 there. That would be the two outside terms. But today, we'd like to call it double distributive property because it's more mathematical and it makes more mathematical sense. So we end up with x squared minus 6x. Then we take the 2 and distribute the 2. The second part of the double distributive property, we distribute the 2 to multiply by both the x and the negative 6. That would be the inside and the last terms to complete the acronym FOIL. So we get plus 2x minus 12. Again, we need to be careful with signs. Then combine like terms. Those two terms can be combined, the negative 6x and the positive 2x, to get x squared minus 4x minus 12. I'd like you guys to try the next example. I'm going to put up 3x minus 2 times 5x minus 1. Again, be careful with your signs, and it may be helpful to complete this the same way as I did. So pause your video, and you can check your answer in a moment. Okay, magically the answer appears here. Hopefully your answer matches mine, and we're both correct. Again, this is review, so it should be fine for you. The next problem I know causes issues for everybody from Algebra 1 up through pre-calculus and calculus is when you square a binomial. What does it mean to square a binomial? It means to multiply by itself. So if I'm going to take x minus 5 quantity squared and multiply it by itself, I'm going to want to rewrite that as the quantity x minus 5 times x minus 5. And here again, I'll use the double distributive property. I think we're probably pretty decent at the double distributive property, but that squared right there makes a lot of people think the answer is x squared plus 25. But that's not correct. That will always be a distractor choice on a multiple choice question as well. So when we do this problem, x minus 5 times x minus 5, we'll distribute the x to get x squared minus 5x. Then we'll distribute the negative 5 to get minus 5x plus 25. Our last step will be to combine the like terms, and we get x squared minus 10x plus 25. This is a trinomial because it has 3 terms. And take a moment and think about what degree is this trinomial. It's a degree of 2 because the x squared represents the highest exponent in the problem. I'd like you to try 3x plus 2 quantity squared on your own. Pause the video, and we'll put the answer up in just a moment. The last 2 problems are a little more complex. They're not any harder. They're still using the distributive property. They're just a little bit bigger and require a little more organization. When I do these, I want to make sure I don't make a mistake because it's bigger, more opportunities to make a mistake. You can distribute these like we did before, make a long line out, and be careful in combined terms. Or, I like this way. You can make a box. I'm going to write out 2x squared plus 5x minus 1 on top. Then I'm going to put the 4x minus 3 on the bottom. I'm going to write it like that so it looks nice. And I'm going to make a box. And inside the box, I'm going to put the answer for when I multiply each term. Basically, I'm going to take the 4x and multiply it by that top row there and get each of the 3 terms. Then I'm going to take the negative 3 and distribute that and multiply it by the 3 terms. I'll have 6 terms to combine. Then I will carefully organize them. I'm going to pause the video so I can do this carefully and not make a mistake like I did in my practice run. And we'll be back in a second. Okay. I did that first row. I took the 4x and multiplied it by that top row and got 8x cubed plus 20x squared minus 4x. I included the signs in the boxes so I can compare them and combine like terms in the next step. I'll take that negative 3 now and distribute it. Get negative 6x squared minus 15x plus 3. Now you'll see here I can combine some of the terms. I can combine the 6x squared with the 20x squared and the negative 15x with the negative 4x. They lined up diagonally. I don't think that's a coincidence. We'll get 8x cubed plus 14x squared minus 19x plus 3. Remember, when you combine like terms, you just add or subtract the coefficient. I'm going to pause the video again, and I'm going to show the work the way we've been doing it before, just so you can see and compare the two, see what you prefer. As you see, the answer worked out to be the same. It's just a question of which way you prefer. But I'm going to tell you this, whatever way you choose, you must show your work. A question like this has appeared on the Regents exam before, even though I personally think it's a little bit of excess, tedious work. I'm going to have a second example. I would like you to try this, and we'll pause the video, and in a moment we'll put it up. If you want to check along the way, I put the first step up. I'll pause again and you can see the next steps. Again, I put this up both ways, so you could use whichever way you prefer. And there are both the solutions. Now, one thing I did want to make a comment of, notice the commutative property of multiplication. You can multiply it in any order. I chose to distribute from right to left versus left to right because I'd rather distribute 2 terms than 3 terms, but regardless, the answers are the same. Now, tomorrow in class, I'll put several of these problems up for you to try as a warm-up. I'll be hoping to see that you've completed this note sheet and you know what you're doing. I think what I'm going to do here is actually put a couple extra questions up here for practice if you want to, kind of optional, just because it's the first time we've done it. That way you can feel comfortable if you've done it. I'll put a couple examples up, I'll pause the video, and then give you time to solve them. Again, this will be optional today. I just think it's a good idea. It's a last-minute impulsive thought, and I'll keep it just at 10 minutes if I do this. Okay, here are the 3 problems. Pause the video and copy them, and I'll put the answers up shortly. I'll give you a little more pause time. Next time, the answers will be up, and we'll see you tomorrow in class. And there are your answers. In the upper right-hand corner, I included a version using the box method for the multiplication of the binomial. That's fine for any size polynomial. Hope you enjoyed the video as much as you can enjoy doing it, and please give me feedback on this tomorrow in class. Thank you so much for watching.